Today we're going to be evaluating logarithms. So your essential question is, what can I do to help me remember how to evaluate logarithms? Now this might be the first time any of you have seen logarithms before, and that's okay. Now this here is just notation, so I don't want you to get hung up on this, and once we start putting in numbers it will look more familiar to you. So if a logarithm has a base b, okay, this is how we say logarithm. So we'd say log base b of y equals x. And then that makes sense only if b to the x power equals y. So logarithms, this might seem kind of confusing right now, but when we put in some numbers, it will be okay. Basically what you're asking yourself is b to the what power is equal to y. So if I had log base 2 of 8, and I'm trying to figure out what that equals, okay, there's something that I use called BAP, B-A-P, to help me remember how to evaluate logarithms. So I label it like this. I label it BAP like this, and BAP stands for base, answer, power. So I'm saying 2 to what power equals 8 as the answer. So you might have to run through that in your head first. 2 to the first power, 2 to the second power. Oh, 2 to the third power equals 8. So in this case, log base 2 of 8 would be equal to 3. Okay, now that's how you would figure it out using the BAP method. Another method that I like to use is the heart method, and some of you girls might be fond of this, or even some boys. And so what you do for the heart method is, I'm going to erase this BAP really quick. You draw a heart, so you would say 2 to what power equals 8, and it makes a little heart. So that kind of shows you what order to go in to evaluate your logarithm, and the answer would still be 3. So those are just a few different ways that you can remember how to evaluate logarithms. So for example, if it says rewrite logarithmic equations, we have a logarithmic form and we have the exponential form. So if I have log base 2 of 8 is equal to 3, if I do BAP, I have base, answer, power, then 2 to the third power equals 8. So that would be the exponential form. Okay, so another example of that would be like if I have 4, log base 4 of 1 equals 0. What I'm saying is 4 to the 0 power equals 1. So you can do BAP or you can do the heart method. So let's try one on our own. Feel free to pause the video and try this really quickly on your own if you'd like to. So really, if I do BAP, this is base, answer, power. So I'm saying 12 to what power equals 12? Well, that would be the first power. 12 to the first power equals 12. Okay, another way to do that would be to do the heart method. So I would do 12 to this power equals 12, which would still be 1. Okay, so to rewrite that in exponential form, 12 is my base, 1 was my power, and 12 was my answer. So that's how I would rewrite that in exponential form. Let's try another one. Okay, this one's a little bit trickier. Okay, this time I have the base, the answer, and the power. So my base is a 1/4, and my answer is 4, and I have to come up with the power. Okay, so because it's a fraction, the only way to move my 4 up to the top would be to have a negative exponent right here. So 4 to what power equals 1/4? Well, it would be -1. So if I take 1/4 to the negative first power, then I would move the 4 back up to the top, and then it would work. So this would be like 1/4 to the negative first power. then that would equal 4. So anytime we have a fraction, we know there's going to be a negative exponent involved somewhere. Okay? All right. So let's go back into evaluating some more logarithms. Okay? So you can do the heart method or you can do BAP. Okay? So 4 to what power equals 64? So you might have to take a minute to think about that or use your calculator. But it would be 4 to the third power would be the answer. Okay, let's try another one. And feel free to pause the video and try some of these on your own. Okay, we have 0.2. This one is kind of hard. And because it's in decimal form, you might want to guess and check with your calculator. Or you could rewrite this as a fraction. So, if we rewrite this as a fraction, put this down a little bit. 0.2 is equivalent to 1/5. So I could rewrite this as log base 5 of 1/5. Okay, the same thing. So if I did the heart method, that would be like saying 5 to what power equals 1/5. Or you can do base. This is the answer. This is the power. Okay, well, I have a fraction, so I know there's going to be a negative exponent involved. So in order to get 5 to move to the bottom, I would have to have -1 as my exponent. Okay, one more. Log 36 of 6. So our base is 36. Our answer is 6, and I have to figure out the power. Okay, so it's like 36 to what power equals 6. Well, this is complicated because my number actually got smaller, and it didn't turn into a fraction, so it's not going to be a negative exponent. But how can I get 36 to turn into 6 using an exponent? Well, I know that the square root of 36 is 6. So what power is equivalent to a square root? And the answer is 1/2. So if I took 36 to the 1/2 power, that would be like taking the square root. Then it would be 6. So the answer is 1/2. So anytime your number gets smaller than your base, you know you're going to have a fraction as the exponent. All right. Now, when a common logarithm is a logarithm that has a base of 10. And so what happens is, and you have this button on your calculator, you have a log button on your calculator. That is only for evaluating logs with a base of 10. Okay? So you don't, if they don't write the base, you automatically assume that the base is 10, if it just says log. Another, so log base 10 of x is the same as just log x. Another kind of logarithm is called a natural logarithm, and that's written as ln, and you have that button on your calculator as well. And this is a logarithm that has a base of e, which is that Euler number that we've been working with. So if it has a base e, then it can be written as log base e, but usually it's written as natural log, which is ln. So log base e is the same as natural log. Okay, now we're going to use a calculator to do these, so this is pretty easy. I want you to just type in log 12 on your calculator. So this is equivalent to log base 10 of 12, which it's like saying 10 to what power equals 12. Well, I have no idea what that is because it's probably going to be a decimal because it doesn't come out even. So you would need to use your calculator for this. So if you just type in log 12 and hit enter or equals, you should get about 1.079. And we're going to round to 3 decimal places for these. And then if you type in natural log of 0.75, that's the same as like taking log base e of 0.75, which I would have no idea how to do in my head because e is like 2.1 8, and so I don't know how I would get that answer in my head. So I would need to use my calculator. So you're going to type in the natural log button, which is ln, and then 0.75. And if you hit equals, then you should get about negative 0.288. All right. So just double check those, make sure you know how to enter those in the calculator correctly. Last thing. Okay, so when we're talking about inverses, we did inverses before where we switched x and y and then we solved for y, but you should know that the log of a number and then that number in exponent form are inverses. So when I write something in logarithmic form and then I write something in exponent form, those are inverses of each other. So if I wanted to cancel out log base b, then I would use b to that power to cancel it out. Those are inverses. Okay? So don't get too hung up on these formulas because it's actually easier than it looks. So what this is saying is that if I take the compositions of these, if I plug in f of x, which is this, into g of x, then I would get log base b of b to the x power. Well, the log and the base are actually inverses, so they cancel out, which is why this just equals x. And vice versa. If I was to take this one and plug it in for x, then the base and the logarithm would cancel out, which would equal x. So that is why they are inverses of one another. So don't get too hung up on these because it'll be easier when you see it with numbers. So we're going to kind of use this to simplify these. Okay, now remember, we just talked about common logarithms. Common logarithms have a base of 10. So if it doesn't say what the base of the logarithm is, then you just assume that it's a 10. So this is the exact same thing as 10 log base 10 of 4. Well, the base 10 and the log base 10 cancel each other out because they're inverses. So the answer to this problem is just 4. So really it's not as complicated as it seems. Okay, if we take a look at this example, okay, we have log base 5 of 25 to the x power. Well, the problem with this is I don't have the same base and the same bases in my logarithm and in my number. So what I have to do is I need to change my number so that it's a power of 5. I want to use 5 as the base. So 25 is equal to 5 to the second power. So what I'm going to do is I'm going to rewrite this as log base 5 of 5 to the second power, and then I have to leave that x there because I can't just get rid of it. Okay, so the log base 5 and the 5 will cancel each other out, and so the answer will just be 2x. So you just have to make sure that these two numbers right here are the same base. So since 25 and 5 were different, I had to change 25 to be something that was a power of 5. All right, so that is all for part 1. So go ahead and make sure that you answer the essential question and write your summary.